the rate at which students memorize Spanish vocabulary is estimated by m prime of t, 0.15. With your permission, I'm going to write t to 1/2, and plus 0.005, and with your permission, I'm going to write t to negative 1/2. M of t is the number of words memorized, and prime of t is the rate they memorize at. M of t is how many? M prime of t is the rate of change. Find m of t if it is known that m of 0 is 0. So, how do I find this? How do I find m of t? M of t is the integral from m prime of t dt. The integral from the differential m prime of t dt gives us the function. Okay, the most general antiderivative. Okay, so I'm going to copy it. The integral from 0.15 t to 1/2 plus 0.005 t to negative 1/2. Don't forget parentheses, dt. Okay. So, point 15. T to 1/2 plus 1 is to 3/2 over 3/2. Oh, I'm so sorry. I forgot about that about 44. Sorry. I will go back to it. Plus 0.005 t to negative 1/2 plus 1 is t to 1/2 over 1/2. Of course, plus a constant c. I have to flip and simplify a little bit. So when I multiply this by 2, I get 0.3 divided by 3, t to 3/2. When I multiply this by 2, I get 0.01, t to 1/2 plus a constant c. When I simplify here, I get 0.1, t to 3/2 plus 0.01, t to 1/2 plus a constant c. But I am told this, that m of 0 is 0. Okay, 0, 0, c is 0. So then the function was determined as 0.1 t to 3/2 plus 0.01 t to 1/2. So this is the function that gives us the number of such and such that they memorize, the function, not the rate of change. We were given the rate of change. So, find m of t if it is known that m of 0 is 0. How many words are memorized in 1 hour? And t is in minutes, careful, and they are trying to trick us into using 1. So we have to use 60. So how many words in 60 minutes? Of course, I'm going to put this in the graphing calculator and plug in 60 and have an answer. So here it is. So you know my habit. I like to put the function in y equals because I can use it for other things, not just one function and one operation. 0.1, and I also like to see the function, and the power is 1.5, and then plus 0.01, and it's the square root of t. Good, that's it. And now I want to plug in 60. So in an hour, roughly, they memorize 46 words. Pretty good. Any questions? Should we work on another problem? Yes, 44. Okay, sorry. I keep forgetting. So let's look at 44. 44, okay, before we choose another word problem. So the integral from 2 plus the cube root of x over the cube root of x dx. Perfect. Again, luckily, there is only one term in the denominator, so I will have to rewrite it as the integral from 2 times x to negative 1/3, oops, negative 1/3, plus this over this, which is 1. Do not try to simplify. You're not allowed to simplify in a sum. This is not a factor. The only thing you can do is separate into two fractions. This over this is this fraction. This over this happens to be 1. So now from here, I have 2x. Negative 1/3 plus 1 is 2/3, divided by exactly the same number, plus the function prime that is 1 is x plus a constant c. I have to flip, and when I flip, I simplify the 2. So this is 3x to 2/3 plus x plus a constant c. That was a good one. Any questions? Any questions? Do you think we need more examples? Can I move on? Anyone, please? Can we move on? Do you think we need to look at more examples? Okay. Very good. The next section deals with something which I think and I hope you're going to find interesting. Okay. So the next one is section 4.2. We're still talking about antiderivatives, but let's suppose the following. Let's suppose I have a very simple function, which is x squared, and I'm interested in find the area under the graph of f of x, x squared, between 1 and 2. So who cares? When I graph x squared, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. So this is the graph between 0 and 2 and 1. So I'm interested in finding this area under the graph of x squared between 1 and 2, this area. The question is, who cares? Why is this so important to find the area under this, the area under the graph of x squared between 1 and 2? Here's the reason why. Assuming now we're going to come back and find the area. First estimate and then find the exact area. So here's the reason why we are interested in areas under graphs. Let's suppose this is the velocity function. Let's say v of t. So t and v. I drive between Baltimore and New York. And somehow I have this function that represents my speed for the duration of the trip. Let's suppose this is it. If I determine this area under the graph of the velocity function, if I find this area, the number, because it's an area, it's going to be 5, 10, 200, 500, whatever. If I find this area, I found the distance covered. Why? Because I'm going back from the velocity to the distance. Remember in the previous chapter, we were given the distance and we were asked to find the velocity. But if I'm given the velocity now in this chapter, we are going backwards with the antiderivative. So if I find this area under the graph of the velocity, I immediately obtain in this process the distance covered. So coming back to our simple example, find the area under the graph of y equals x squared between 1 and 2. This is the purpose. But let's look at a very simple example to see how it's done. How do I find that area? At first, we're going to approximate the area. I don't like this anymore. Let me get a new one. First, we are going to approximate the area under a graph. Then we are going to determine the exact. Later, find the exact. But right now, we're going to approximate the area under a graph. Okay. So I'm going to get a nicer function. Same idea, but a nicer function. So let's say we have x squared plus 1. And the interval we want to look at is 0 to 4. So what am I trying to do? I'm trying to approximate the area under this graph of x squared plus 1 between 0 and 4. And we have several options. I'm going to list the options. One option is leftmost point. Another option is rightmost point. And the last option, which we're not going to cover, but I just want you to know that it exists, midpoint. I normally cover this in Calculus 1, but it's not in your book, so I just want you to know it exists. So we're only going to look at these two, not the midpoint. Okay, so what is all this? Sounds difficult. No, it's not. Bear with me. So here's the graph again. 1, 2, 3, 4. And this is 1. So 16 plus 1 is 17. So for, I'm just going to graph it without points because I cannot go 17 units up unless I say 4, 4, 4, 4, and this is 17. That's fine. Okay, so at 4 is 17, and here's the graph. This is a graph of x squared plus 1. And we're asked to approximate. This time I'm going to use leftmost point. I'm also told from the very beginning, use 4 subintervals. Okay. I'm going to use 4 subintervals. So here's the first subinterval, here's the second one, here's the third one, and here's the fourth one. 1, 2, 3. From 0 to 1, from 1 to 2, 2 to 3, 3 to 4. They're all the same width. Now, what does the leftmost point say? The leftmost point means for the first subinterval, use this as the reference. For the next subinterval, use this, the leftmost point. And for this one, this, and for this one, this. I'm going to create rectangles. So with this height as the leftmost point, and then with this height at the leftmost point, and then with this height using the leftmost point, and this height using the leftmost point. What does this mean? So the first area will be estimated by this. The second piece will be estimated by this area. This third one will be estimated by this, and the last one by this. So the area using the leftmost point with 4 subintervals is base times height plus base times height plus base times height plus base times height. This is the area of each rectangle. The base is always 1, so I'm going to take it out. F of 0 plus f of 1 plus f of 2 plus f of 3. Okay, what is this? 1 stays outside, it's 1. F of 0, 0 plus 1. F of 1, 1 plus 1. F of 2, 4 plus 1. And f of 3, 9 plus 1. So 18. Is this a good estimate? No. It's an underestimate. How come? Because I'm missing this piece, I'm missing this piece, I'm missing this piece, and missing this piece. It cannot be close. If I have more subintervals, yes, it will be better. If I have from 4, if I go to 8, or 16, or 32, or 200, yes, the estimate will be better. But right now, it's an underestimate. Okay, this is with the leftmost point. I'm going to repeat with the rightmost point. Okay, I don't want to put it there, so I'm going to graph it again. 1, 2, 3, 4. So let's say the graph is this. So the rightmost point, the area with the rightmost point with 4 subintervals. 0, 1, 2, 3, 4. Rightmost point means the reference point is here, and this is the height. The reference point is here, and this is the height of the rectangle. Rightmost point, and this is the height. Rightmost point, and this is the height. Well, this is the first interval and rectangle corresponding. This is the second, because that's where the height is. The height is on the right now. And the height. Obviously, this is an overestimate by this piece, this piece, this piece, and this piece. How do I write it? So this equals here. Again, the same thing, 1 in front. But now I have f of 1 plus f of 2 plus f of 3 plus f of 4. Base times height plus base times height plus base times height plus base times height. Okay, f of 1, I have it, is 2. F of 2, I have it, is 5. F of 3, I have it, is 10. 16 plus 1 is 17. So 17 plus 24, 34. The exact area is definitely between 18 and 34. This is an underestimate, and this is an overestimate. So what will be the midpoint? Which I'm not going to present. It will be here, right here. So let me just show it to you. And the midpoint will always be a better estimate. You don't have to do anything with it. I just want to show you how it looks like. So the midpoint is here. And this is the height. The midpoint is here. And this is the height. The midpoint is here. And this is the height of the rectangle. The midpoint is here. And this is the height. So the rectangles will be much better. And the approximation will be, and the error will be lower. There is no need for you to do this because we're only asked to look at the leftmost point and the rightmost point. The exact area is somewhere in between. It's not 18 and it's not 34. This is an underestimate and this is an overestimate. Any questions? Any questions? Any questions? Okay. I don't think I have, I only have 1 minute. Okay, I wanted to, let me just show you. We're not going to do anything, I promise. Let me just show you on the page 402. You cannot and you should not start 4.2, but please finish 4.1. Oh, I'm already signed out. Okay. So approximate the area under the following graph of this. This is the graph over the interval 1 through 7. Good. Computing the area of each rectangle to 4 decimal places and then adding. They're not telling us if to use the leftmost point, the rightmost point. Okay, so when we are not told, we are using, they're telling us 4 subintervals, but they're not telling us to use leftmost point or rightmost point. So we're going to work on these problems on Thursday.